In this set of slides, we'll talk about the blink example, a piece of code, a very simple piece of code that everybody needs to run on their Arduino just to make sure, to sanity check it, to make sure everything's working. So we'll just walk through that example. We've learned basically all the pieces that we need to know to be able to write that piece of code. So one other function call that we need to know to be able to do the blink example, a very useful function, is delay. So delay, if you look at the function, it takes one argument, msec, or milliseconds. And it basically pauses the program for a certain number of milliseconds. So 1,000 milliseconds being a full second. So if you have a delay for 1,000, that's a second delay. It's useful for a lot of things. Human interaction is what we're using it for a lot. So by that I mean machines, microcontrollers are fast, right? Even slow microcontrollers run at 8 megahertz, right? But that's 8 million cycles a second, something like that. But humans are slow relative to that, very slow compared to that. So there's always this human-computer interface going on with these Internet of Things devices, because these Internet of Things devices are always dealing with humans, or most of the time are dealing directly with humans. There's some kind of a user interface, right? And this user interface has to be slowed down, right? It has to be at the speed that a human can perceive it, right? So you can't just output some data and expect the human to read it in one clock cycle and then change it. You got to, if you want the human to see something, to hear something, it has to be present for a certain amount of time, or else the human can't even perceive it. So you get this problem a lot where you have to delay things inside your microcontroller just so the human can properly perceive whatever it is you're trying to give to the human. So here's an example. We've got digital write pin 3 high. So that sets pin 3 high. Then delay 1,000, so that waits for 1 second. And then digital write 3 low. And what that does is it just sets pin high for 1 second. For whatever reason, it sets pin high for 1 second. So that's pretty simple what delay does. But it's not, just to let you know, it's not particularly precise as far as timers go. It depends, but certainly for what we're using, it's good enough, right? You can get better precision timers using other functions, but delay is sort of the standard function. It makes it nice and easy. And for human interaction, it's more accurate than we actually need for this purpose. Okay, so the blink example. So blink is your generic embedded system example. It's like Hello World. So if regular C programs or any kind of program, Hello World is often the first program they teach you. Just how to print Hello World just to make sure you can get something running. But you can't use Hello World for embedded systems often because we don't have a screen, right? There's no screen on which you can print Hello World. But almost every embedded system has an LED. So blink example is sort of a common example that you can use on basically any type of embedded device, and just check it out, see if it works. You just blink the LED. So that's all it does. It makes the LED blink. You can find this example if you go to the Arduino IDE, go to File, under Examples, under Basics, there's a blink example. So you select that, and it will pop up a window that has the code for blink. Now notice when you look at the code for blink, there are a lot of comments inside that code. You can read those, but understand that they are not executed, right? So on the next slide, I show you the blink example without the comments, and it is very short. So what happens on the Arduino, this blink example, it blinks in one of the LEDs built into the Arduino. So there's an LED built into the Arduino Uno that is connected to pin 13, and actually is right next to pin 13. So you see in the picture, we're zooming in on digital pin 13, and you see it circled. Then just to the side of it, there's this tiny LED. It's a surface mount LED, so it's very small. But when it's blinking, you can see it. So there's an LED there, and that thing is going to blink as a result of running this program. So the sketch. So the sketch, if we look at the outline of the sketch, we got 2 functions, void setup and void loop. So setup and loop, which are the 2 functions that you need in every Arduino sketch. So in the setup, all we do is say pin mode 13 output. We take pin 13, which is the one that we want to change because that's connected to the LED. We make it an output because we want to assign the voltages on that pin. So we set it to be an output, and you do that in the setup because you only need to do that once right at the beginning of the program. Now then in the loop, the thing that will happen over and over, if you think about a light that's blinking, it should blink. This loop has to describe how to blink once. Okay? And remember that this loop function is automatically executed over and over forever. So if this loop function just blinks, causes it to blink one time, that's sufficient because it'll automatically be called forever. So void loop, what's in there? First line, digital write 13 high. So we turn on pin 13, make it high, 5 volts, which will turn on the LED. Then delay 1000, so you hold it there for a second. Then digital write pin 13 low, you turn it off, and you hold it there for a second. And that's it. And that just gets called over and over, and the light blinks, and you should definitely try this. Thank you.